Now let's go ahead and take a look at one more example. And the question is still, is the relation a function? And our relation is in the form of equation, x plus y squared equals 8. Now, in order to determine whether an equation is a function, it's important that the y is solved for. So if it is not, then you need to go through the algebra to get the y solved for. So you need to get the y by itself. So I'm going to go ahead and rewrite my equation. So x plus y squared equals 8. And what I'm going to do is I'm going to go ahead and solve this equation for y. And the way I'm going to do that is I'm going to go ahead and subtract off x from both sides so that the y value gets isolated. And I'm left with y equals negative x plus 8, since it was a positive 8. And then in order to get rid of this square so that I'm only left with y, I need to take the square root of this left-hand side of the equation, which also means I need to take the square root of the right-hand side. And when I do that, I am left with the absolute value of y equals the square root of negative x plus 8. And then, as you guys know, whenever you're given an absolute value equation, it actually splits into two separate equations. And the one is where you write y equals exactly what you see, which is the square root of negative x plus 8. And the other is where you get y equals the opposite of what you see. So put a negative sign, square root of negative x plus 8. As you can see, when we solved for y, we got two separate equations. So that's saying that y is taking on two values for every x that we input. And so it may not be obvious at that point that this relation is not a function, but it may be if you realize that this y is taking on two values for every input. Now, I should technically correct myself there. It's possible that those two equations result in the same value, which we would see when we have the input x equals 8. So if we were to put an 8 into both equations, we would see that the one results as a positive 0 and the second results as a negative 0, but either way that's still 0. So for the input 8 we get a single value. So 8 has the single value, has the output of a single value of 0. Now, if we were to do the same and we'd put the input of a negative 1 into our function, we would see that when we put a negative 1 into this first equation, we get back a positive 3. But when we put negative 1 into the second equation, we get back a negative 3. So that negative 1 is mapped to two different places, 3 and negative 3. So right there, that should trigger that this relation is not a function. So if you couldn't see it right at the equation step, you can now see it in this table of values that you drew off of those equations. And then the same respect, if you were to put in, let's say, the value of negative 8 into both equations, in the first equation you'd get back a positive 4, and in the second equation you'd get back a negative 4. So again, resulting in the fact that this relation is not a function, as negative 8 is mapped to two different values. Since the equation actually resulted in two different equations, when we go to graph the equation, we can almost think of it as two separate graphs coming together to one graph. So if we were to go and graph y equals the square root of a negative x plus 8, and we plot all the points associated with that part of the equation, we'd get this curve here, which is appropriate for a square root function. And if we were to graph the y equals a negative square root of negative x plus 8, we'd see that our graph would, again, we'd have that point of 8, 0 in common, but no other points would be in common. And so you'd get the second part of the graph down here, which is kind of mirror imaged on the negative half of the y's. And so at the end of the day, if we were to go ahead and apply our vertical line test to see whether this graph is a function or not, we could draw a vertical line, we could draw a vertical line out here and we'd see, okay, well that's okay as far as passing the vertical line test, even if we intersect here, we see, oh, that passes a vertical line test. And so at this point, I might think that I have a function. But if I were to draw a vertical line anywhere else on this graph, going in this leftward direction, I'd see that I'm intersecting the graph at more than one point, so two or more. And so in that case, I am not a function, and so this relation is not a function. So you can see it on the equation level, you could make a table of values and see it on that level, you could graph it and see it by applying the vertical line test, but either way, this relation is not a function.